So to change the simple interest, somebody tell me, have you done number 5? Has everybody done 5? Do it real quick. These we should be able to get through really quick. Then put the answer on your whiteboard so I can see if you are getting it or not. Put your answer on your whiteboard. That's going to tell me real quick. It's a way that I can check what you're doing as long as you're just not taking your neighbor's answer. Okay? Your neighbor's not going to be there in a test. Well, they're going to be there, but you're not going to be able to see their paper. So don't just take their answer. And everybody should have a whiteboard because I gave everybody one. And if you're not bringing it to class, then you're not bringing your supplies. Showdown. You should have, okay, put that down. This says P times R times T, correct? To undo multiplication, what should I do, Matthew? I should do division. And I'm going to divide out both the R and the T, because I want P left behind. So if I divide out RT from both sides, my final answer is I divided by RT equals capital letter P for principal. Okay? If you didn't get that, and I looked, there were a few of you that had, it looked like you tried using addition. Can't use addition to undo multiplication. Okay? Surface area. These are the ones that are because they're larger, they seem to cause more of a struggle. Okay? Right now, distributive property has been used. So I need to undo that distributive property. I need to factor out what both of the add-ins have in common. Okay? And if I factor out what they have in common, what would I be factoring out? I've got 2 pi r squared plus 2 pi r h. What do I factor out, Michaela? 2 pi r. So 2 pi r comes to the outside. 2 pi r squared divided by 2 pi r, what's left behind? R. And then 2 pi r h divided by 2 pi r, what's left behind? It's the h, isn't it? Okay. Does that right there cause you a problem? My question is, do you see what's going on there? Okay, here's what's happening. 2 pi r r. Is that the same thing as what's written right there? Okay. And if I divide out 2 pi r, I can simplify fractions, right? And I can factor out here, here, and here, and what's left behind? The r. And that's why I have r here. And the other one's the same thing. I've got 2 pi rh, and I'm going to factor out the 2 pi and the r, and then I'm going to simplify. The 2's come out, the pi comes out, the r comes out. What's left? H over 1. Does that make sense to you now? Do you know what's happening and why that's working? Okay. Here's another example. Let's try using numbers. Remember the bow tie? You remember the bow tie that we used to do?
No.
If I said 2 times 3 times 5 divided by 2 times 3, what would your final answer be? Could I factor these out?
5.
So that would be 5. Well, what's 2 times 3? Times 5 is 30 divided by 6. Do you get 5? Just the fact that I'm using letters instead of numbers doesn't change the properties of multiplication and division. Okay? so I can still factor it out the same way. Does that help? Okay, with that being said, so now I have S equals 2 pi r times everything in the parentheses. I want H alone. This is what I want alone. So, I've got multiplication. I'm going to work it backwards. That says distribute. To undo multiplication, I do what? Division. So I'm going to divide both sides by 2 pi r. These two cancel each other out because 2 pi r divided by 2 pi r is going to give you 1. So I have S over 2 pi r equals r plus h. H is what I want left behind. How do I undo addition? Subtraction. Or I create that 0 pair, so I'm going to subtract r from both sides. So I have S divided by 2 pi r minus r equals h. Good, Darton? Landon, do you see where all that's going and how it's working? Okay. I could have said, keep these together. Okay? And if I keep that together, if that's a group, can I subtract r from that? No. That's why it's out here by itself. Okay, that's why it's by itself. Fist to 5 on that problem. What's happening there, that you understand what's going on. 5 means, yeah, I could do it all day long. 4, I'm getting there, and anywhere from below. Okay. Very common formula. Celsius converting thing, Fahrenheit to Celsius. Okay? You'll see this formula for temperature conversion in science. Okay? Scientists use it all the time. Okay? Now, I want to take that same formula and solve it for the F. So I'm going to go back to that formula, and it's C equals 5/9 F minus 32. C equals 5/9 times F minus 32. This is exactly like the one we just did together, that I modeled for you. Exactly. Okay? So what am I going to do first? I want F. I want the F alone. So, what am I going to do, Paige? Divide by 5/9. Divide by 5/9. Okay? 5/9 divided by 5/9. Do we ever divide fractions? No. But 5/9 divided by 5/9 would give me 1. Do you agree?
Yeah.
3 divided by 3 is 1. Okay? So these guys are going to cancel out, leaving the F minus 32 behind. Now, we said we don't divide by a fraction. What do we do instead of dividing by a fraction? What do we do instead of that, Trenton?
Multiply it.
Multiply by its reciprocal, or its opposite, okay? So we stand, remember, Kentucky Chicken Fried. Keep, change, flip. So we're going to flip this, and now we have 9/5 C. Do you agree with that? I just flipped it. Keep, change, flip. Okay? What What letter are we trying to get alone, Zoe? F, okay. Savannah, how do I get F by itself? This says minus 32. Add 32, good. Plus 32 to both sides. I have 9/5 C plus 32 equals F. And that's as far as I go. I solved for the letter F. I don't know what the temperature is still, do I? I don't really know what F is. But if I'm given Celsius, I know how to calculate F. Okay? If Celsius was 2 degrees, what would F be? You got a calculator. If Celsius was 2 degrees, what would F be? What would its Fahrenheit be? Please don't blurt. Did everybody plug it into their calculator? 'Cause that's so easy to do. (9/5) times 2 plus 32. What is the degrees in Fahrenheit? Cooper,
35 and 3/5.
did you say 35?
Yeah.
35 is degrees Fahrenheit. Do you agree?
Would we say 36 because it's 0.6?
Would you round it to 36? If you're gonna round, yes. Was it 0.6,
It was
Andy?
3/5,
Yeah, it
so
was 3/5.
but that's 0.6. So.
You would probably say 30, if you're gonna be accurate, because it didn't ask for an estimate, you should have said 35 degrees and 6/10.
Yes.
35.6 degrees Fahrenheit. Yeah, okay. Yeah, it's kind of cold. Just above freezing, isn't it? Because, isn't 32 the freezing point?
Yeah.
Okay, which is the same thing as 0 degrees Celsius, absolutely correct. Okay? Now, we've done the temperature thing. So we've got to know, what was that formula? 9/5 C plus 32 equals degrees Fahrenheit, right? Which has a greater temperature? Which has a greater temperature? Lightning or the sun?
Oh, yeah. It's definitely.
The sun, lightning. If you say lightning.
I looked at it. I was about to say that. Yes.
Calculate it.
It's a negative.
Do the calculation. Which temperature is greater? Is it the sun or is it lightning at 30 degrees Celsius? Is 11 degrees Fahrenheit the sun or is the lightning? Which one is hotter? It's really what it's wanting to know, which is hotter. How hot is the lightning, ladies and gentlemen, when you converted it? Somebody raise your hand for me. Landon. 54,032 degrees Fahrenheit. So who's hotter? The sun or the lightning? It's the lightning. It's got the greater value.
Wow.
That's that burst of energy.
It looked like it.
Would anybody have ever thought that? to
Well,
be a true
are those
statement?
the accurate temperatures?
Yeah.
I don't think those are right.
I don't know, I'm just going by this.
Because the sun.
Okay, I hear a lot of people yell, I hear one yelling, and I hear a bunch of rumbling, and one's yelling, trying to get above it. Okay? Thinking that's not the way we need to do things, okay? So let's turn it down. Maybe the question would be to ask your science teacher, Mr. Shields, today, how is that possible?
Or looked it
Yeah.
Google it.
Or read them all if you want.
No, I'm not, because I'm gonna go on. Okay? I want you to have time to work on your assignment. Okay? Do you see how that conversion, though, of the original formula made it easier to solve for the degrees Fahrenheit? Would have been a lot tougher, wouldn't it have? Going back to that same formula. Again, we had 9/5 C plus 32 equals degrees Fahrenheit. The room temperature is considered to be 7 degrees Fahrenheit. That's pretty close to what we keep it at in here. Suppose the temperature is 23 degrees Celsius. Is this greater than or less than the temperature of this room? Oh, I got stuff in my calculator. If we were 23 degrees Celsius, is that greater than, less than, or equal to 70 degrees Fahrenheit? Michaela? 23 degrees Celsius is greater than, because 23 degrees Celsius figures out to be 73.4 degrees Fahrenheit. You can't compare Celsius to Fahrenheit. You have to convert to know the answer to that question. Have to. Okay? It's like comparing apples and oranges. You can't. You've got to be able to convert them to the same increments. There is your assignment. Yes, sir.
If it was 21 degrees Celsius, it would be really close to.
Right. Wesley, come here, bud. You actually have 5, 10, 15 minutes that you could be working